Okay.
Hopefully they're coming. We are recording right now.
Perfect. I do this icebreaker when there are bigger teams, but if people want to put in the chat where they're calling in from, like your company, location, I can kick it off. All right. I went ahead and kicked it off. If everyone wants to put like their name, this is just a fun thing we do in the beginning, just to see how many people are calling in from different companies, geographical locations. Yay. Yay, Jessica. Awesome. Oh, love that. Oh, nice. Ontario, Canada. Fort Worth, Texas. Philadelphia. Love it. We have a good representation. High Point, North Carolina. Very cool. Pittston, Pennsylvania. Oh, yeah. Nice. Hi, Beth.
Hello. How is everyone?
Great. So do we have Beth, Dan, and Russell?
Beth and Russell, and Dan will be
Yeah.
joining. I'm not sure if Dan is here.
I
We're all
see him
calling in.
going
You
into a
see him? Okay. We're all calling in from our microfactory in Oakland, California, but just
Oh,
in different booths.
fantastic.
Are you in a booth too, Russell? Yeah.
We're so excited to have you guys for this material interest group session. I've been hearing about UnSpun from various trade shows and conferences, and so I thought it would be a fantastic topic to have for our AATCC members who are very technically oriented, and thought that 3D weaving would be right up their alley.
Well, thank you for having us. This is, it's like an honor. You got 3 of us because we're all like, we couldn't share and we all wanted to see what was going on. No, we're happy we'll share together.
I think we still have some people coming in, and we will probably just get started in maybe a minute or two.
Yeah, this looks like a very good crowd. Everyone, please keep your questions ready, because at the end we'll have a good question and answer session. And this meeting is really just for you guys. So if you have any questions for them, would be wonderful to hear from the audience. And the questions will be in the chat. Right now, the chat's being filled with where you're from. So if people want to just share where they're calling from, who they are.
Okay. Well, Apurva, do you think we should kick it off?
I think so too, yeah.
All right. All right. I'll start by introducing myself. So I'm Christina Ratham, the current Materials Interest Group Chair for AATCC. I'm also a textile engineer at W.L. Gore & Associates in Elkton, Maryland. We're very excited to have UnSpun here today to talk about 3D weaving. And Apurva, would you like to introduce yourself?
Yes, absolutely. Hi, my name is Apurva Banerjee. I am at Standard Textile in Cincinnati and also a research scientist in the research and development group. I'm excited to learn a lot about 3D weaving. We had at least 4 people in our company message me today that you have to give me a debrief. So I'm taking ferocious notes while you guys speak. And before we kick it off, I just wanted to quickly mention this is Christina's last.
It's like a speaker.
Material.
Oh,
This is Christina's last meeting as the Materials Interest chair, and I really want to thank you, Christina, for continuously bringing us wonderful speakers every single. Yes, let's do the little clap emoji, everyone. There's the little. I do the reaction button and do the little clap.
Yay. Yeah, this is my 4th year.
Yeah, thank you so much, Christina.
4th year is MIG.
Yeah.
And Apurva will be taking over starting January 1st as the new Material Interest Group chair. And she'll have a vice chair helping her out next year. So more to come. We do this every 6 months or so. So if there are interesting companies that you want to talk to, reach out to Apurva, let her know that they could be a great topic for the Material Interest Group, and she'll reach out to them and get it set up. So, but I'm not going anywhere. I'll still be with AATCC next year as the president elect, aka president. So
Amazing.
I'll be around. Mm-hmm.
Claps to
Okay.
for that.
So, housekeeping rules. This is your session and a chance to have your questions answered and opinions heard. If you have questions, comments, or opinions, speak up. Ask your questions or make comments by speaking up aloud, texting in the chat, or by raising your hand. We are recording this session, so if you do not wish to be recorded, please mute your webcam and participate via the chat function. Of course, if you want to ask questions throughout the meeting, the best way to do it so as you're not interrupting is to put it in the chat. Apurva and I at the end will go through every single question and have that QA session with Beth, Russell, and Dan. Okay, so meet the speakers. UnSpun has graciously agreed to be with us here today. They are a startup 3D weaving company out of California. We're lucky enough to have Beth Espinette as the co-founder of UnSpun speak to us today about her company, as well as Dan Robichaud-Carew, head of software and product management, and Hannah Russell, the R&D textile engineer. Next slide, or is this it? Then we go, okay, perfect. Now I'd like to turn it over to Beth and Russell, or Hannah, should I say Hannah? Russell, to introduce your company to us. Thank you very much.
Well, thank you so much, Apurva and Christina. I'm really, really excited to be here. When we got invited, Russell, Dan, and I all were very excited to join forces and talk with you. We're going to spend probably 30 minutes on our part and leave the end, which is really the best part, we think, is the Q&A, and especially with this group of people. We're just super excited to hear what kinds of questions you have for us. And as we're going along, if you want to take down advice and tell us, give us some bits of advice at the end too, we always appreciate that. I just want to see, is Dan here? Okay, he might not be here yet. So if he ends up,
You might.
we got Dan.
Yeah.
We got him. Okay. All right. I don't know why my computer's not seeing him. Okay. I'll do a little screen share. And so I'll start and introduce high level about why UnSpun exists. And then I'm going to pass it off to Dan, who's going to dive into the technology at a high level and like the platform, what we're going after. And then Russell is going to close us up with really the physical, like what we have physically done so far, and give you a glimpse of what the next steps for our company look like. So again, going for about an hour, I think. So feel free to cut us off if we go too far. So UnSpun has been around for just over 7 years now. We feel, in some ways it feels like a blur. It's gone really fast. In other ways, it's like this, been doing this my whole life. It is hardware. So hardware takes a long time to develop, and you're talking to us on a day and a week and a month that is just like a very pivotal time for us, where we're really starting to move towards execution and action and scaling up. But going back to the beginning of like why we exist, this is again like 10 years ago now, coming from school and seeing like the really romanticized version of fashion. It's all about, self-confidence and expression and glamour, and then seeing behind the scenes of actually what the fashion industry is driven by was incredibly disappointing for me. And there's just, as we all know, we're kind of like speaking to the choir here, there's just a lot of waste, and the supply chain is kind of over optimized. So every little piece works really, really well in a silo, but you back up and you see that it's extremely reactionary. It's very much a guessing game, because you'll put in an order for what you want. It's a large, large amount in order to hit those economies of scale. And it's a lot of days ahead, it's months and sometimes over a year ahead of time before you actually are going to sell anything. So given the speed that the world works at today, and especially some of the issues that have hit us like COVID and wars, like it's just really hard to predict where the world's going to be. And it's also just hard to predict, like, what color will people want? What size will that person be who shows up? What geography are they going to be in? What's the weather going to be like? Is that shape, that silhouette, like fashionable right now? Is that material something that people like? There're just too many variables to get it right. And we felt like it was backwards. So we started to ask the question, could we make this on demand? Right now, we put in an order, cross our fingers, hope that it sells later on. And that is driven by a technology that was invented in the early 1800s by the sewing machine. I love the sewing machine. I love sewing, but it is extremely manual, and no one has figured out how to automate it yet. And to us, it didn't feel like automating the sewing machine was really the right thing to do. It felt a little too zoomed in. Instead, it was thinking about the question from a further off, just like backing up, like what technology exists today that didn't exist back then? What kind of technology could we develop so that making on demand could be possible and actually make sense, and even allow us to design for disassembly, where it's a fully thought out cycle and not just let's take the resources that we have and then turn those into trash, which is essentially what the industry kind of functions on right now. So this was a question that we started with. Could we start with nothing, build up a product in a way that could kind of support someone buying something and then receiving it perfectly to their needs? So since then, we've really tried to make sure, like, we don't want to exist and for no reason. We want to make sure that the initial reasons that we started this still reign true. So we've continued to do LTAs on our technologies that we've built and our processes, and then became a B Corp. We're getting recertified right now, actually. Just became a PBC, a public benefit corporation, 3 months ago. So we really, really want to always make sure we're checking ourselves, because we shouldn't exist anymore if we're starting to move things in the wrong direction. And Russell's going to talk a bit more about Vega and our 3D weaving, but I guess what I will do is talk to you about just like so I told you about the why, maybe just the initial experiments that we did that landed at 3D weaving, and then after Dan goes, and Russell will pull it back to 3D weaving. So starting with that question of how can we make products on demand, we started looking at inspiration, like what we call analogous situations. Where is that possible? And 3D printing is a technology that inspired us. Looking at the growth processes of nature, growth and decay really of nature and the cycles behind it was another inspiration to us. 3D knitting was a pretty obvious inspiration, jacquard weaving, all sorts of weaving, thinking about like pieces, like small fundamental pieces or elements being added together to build a whole. So I guess more holistically, like additive manufacturing was very inspiring to us. And as compared to like subtractive manufacturing, like right now sewing, cutting and sewing is a type of subtractive manufacturing where you start with something that's bigger to get something that's smaller, like you whittle away and they're byproducts. Additive manufacturing, meaning that you start with nothing, you add pieces and there's no waste in the process. And what's cool about additive manufacturing today is just the technology is amazing where you can have so many controls that you could actually make products one off and have it be the same efficiency as if the product's going through, if they were all the same, it'd be the same as if they were all unique. So that's something else that we're incredibly excited about with our technology. So going back to like, okay, those were some things that inspired us. Some things we tried were really, really backed up, really experimental. And I think that did lead us, like it allowed us to think a little more creatively than just like an incremental, like if you kind of hold yourself in the current method and you say, how can I improve this? It doesn't allow you to think bigger. So some of the experiments were around growing like chia clothing in gardens, looking at like kind of creating like a human 3D printer using like hot glue and water, building around last to create like more hot glue shoes. So we had very, very humble beginnings. And then once there were some stepping stones that were like, this is interesting because we can create something with no waste and it can be customized very easily, but these materials are all wrong. So then we started to experiment with materials and realized there's nothing wrong with yarn. Yarn in itself is additive, and we can build products that people want to buy, want to wear today using yarn. Why don't we pursue that? And then with that, the kind of architecture of 3D weaving started to take shape, if you will. So I think that I'm going to skip over that. And I think I'm going to pass it on to Dan, who's going to talk to us about the platform and the technology that we've built in the last 7 years.
Okay, great. Can you hear me, by the way?
Yes.
Okay, great. Hello, everybody. Really happy to be here. I'm Dan. I head our software team and product management here at UnSpun. Beth, could you go to the next slide, please? So we at UnSpun started off in the early days. One of the first products that we brought to market was our custom-made denim. And basically the idea there was traditional made-to-measure is a slow, costly logistical nightmare. And we wanted to get to an answer of how is that something that we could do more at scale and really come to a deep understanding of human bodies and pattern making, and even some of the like more messy questions of when somebody complains about something not fitting, even if you had the world's best tailor measuring them, but they still don't like the fit. What went wrong there? And is it that not the right questions were being asked? And how do you handle something like a return? So we've gone through a lot of iterations on this, a lot of improvements, and we're very happy with where we are now, though we still are improving this process. Basically, we've got an app, the UnSpun app. If you have an iPhone, you can download it. You can also go to unspun.io on the web. And with this app, you can take a 3D body scan where you stand in front of the camera and sort of spin around. And we take measurements and we generate a 3D avatar. You can see an example of one there in the middle. And we select certain points of measure on the body. And we use that to then automatically create a pattern. We're at the point now where about 70 to 80% of patterns that we automatically generate are right, or they are correct right from the start. And so only about 20% require somebody to go in and make manual changes. And that's a big improvement over where we started, where everything, of course, was being manually set up. Next slide, Beth. So we've already sold over 10,000 garments. We have achieved a return rate less than 10%. That means that when somebody gets one of their jeans, fewer than 10% of people are sending them back to us. You can see here two different bodies with the same style of jean and sort of the flexibility that we have there. We feel very happy with our deep understanding of bodies and 3D scanning. And we asked ourselves, okay, what comes next? Obviously, not every brand can do fully, made to measure 3D body scan clothing, but how can we help the industry more broadly? And that's sort of where we go next. So Beth, if you could, next slide, please. So we've launched with some partners and continue to develop this a fit software, and this is two parts. The first part, you may have seen products like this before, where you answer some questions about yourself on like a website, and they give you a size recommendation. That's the first part of what we're doing here, where somebody takes a body scan, and then we can recommend, hey, you should be wearing this size garment. And if you want something that looks a little bit different, maybe you're buying a sweater and you want a tight fit or an oversized fit, we help you understand that side of the decision-making process. This can be really tough when different brands, different garments within a certain brand all maybe have different size charts, different graded nests, where a customer might have a hard time knowing exactly what fits them right. And so they buy multiple garments online. They buy a small, a large, medium, and then they return what doesn't fit them. Or they just leave it in their cart because they just don't have that confidence that what they want to buy is the right thing. Or they buy the wrong size and then they just hold on to it and it goes in the trash. Or maybe they donate it and then that goes into the trash. So we want to help with that side of the problem, of helping people understand what the right fit is for them, and using our years of experience with body scans and patterns, we've come to this point. Next slide, please. So the really cool thing that we can do once we have enough people who have scanned, people scan themselves, get a size recommendation, and then we can help the brand actually improve their graded nest and their pattern making, where we can say, hey, look, it looks like you're a little bit off. For some of these people on the left-hand side of the chart, people on the top right, you're not really suiting them well, and we can make recommendations. And because of all the pattern history that we have, we can do this in a semi-automated way as well, and that'll only continue to get better. Next slide, please. So then where does this plug into Vega, our 3D weaving machine? Well, we've got something that we call Vega OS. Vega OS is our tool that is used for designing basically tubes and different patterns that our 3D weaving machine can make. And maybe you've got some ideas for new sizes or new designs. You say, well, I've got, a size 28, a 30, a 32, a 34, but I really want to try a 31 or a 33 in between those. And spinning up a whole new production of thousands of garments being made overseas can take a long time, and it's a big risk to make, big risk to take. And so if somebody instead can very quickly generate a pattern and then produce it on a Vega machine, they can much faster understand, hey, is this something that I can take to market? This is something that people are buying. This is something that fits, and they feel happy about. And then when you validate that, then you can really ramp up production. Next slide, please. So this is the last of my slides. One of the really cool things that our design software allows you to do, this is an image of one of our co-founders, and this image has been sort of like an internal meme at our company for years now. And We can take images like that and put them onto our loom and then have full jacquard control. And using our design software, you really have pretty complex capabilities to do things like that. Yeah, that's it for me. Take it away, Russell.
Cool. Thank you, Dan. Hey, I'm Russell, R&D textile engineer here at UnSpun. Been here for about 3 years, and yeah, I'll talk you a little bit through the hardware itself that we call Vega. So yeah, like Beth said, these supply chains in the industry are extremely complex. You're going from yarn to weavers to dye houses to cut and sew, and it's flying back and forth and everything like that. And so what we thought that the challenge, we have all of these new materials on the market, that's fantastic. But if you produce with waste in mind, you're not going to move the needle to the point where you're actually helping reduce these CO2 emissions and reduce waste throughout the industry. Next slide, please. So what we did is fully automate this system. And when we talk about automation, we're not just talking about a robot arm moves it from one table to another table. We have taken these steps that were once thought to be fundamental and have completely removed them. So we go from yarns, think about your standard 4-pound milk cone. We load it into our machine and we weave it directly into that tube. We all just wear different sized tubes for our garments. So yeah, you're able to remove a lot of those steps that were once thought to be necessary. Next slide, please. This should be a video. Let's see if it can come up, help you visualize it a bit better. Yeah, so I need to thank our branding team for that beautiful image. I can't take credit for it, but that can give you a bit more context of the yarn that we put in and how we insert our wefts and everything like that. So I was lucky enough to show up about halfway through our proof of concept machine. It was a little bit of a smaller scale, working around with around 700 yarns input into the loom, and we've now scaled that up to around 3,000. So yeah, as you can see with this first image, we're loading up those packages. We've run ours down in that photo a little bit. They go directly into our 3D weaving machine. We create those tubes, and then one tube is connected to another with the front rise, zipper, button, and a back rise, and boom, you have a pair of pants. I need to thank Dan for our design system. It's very fun to play around with that, to do different testing metrics. If I want to run a test, see if I can create this funky fabric. It's also so cool because I could be like, hey, I need a button to do this, and then like a month I have a new button in the software. So it's been really fun. Next slide, please. Yeah, so we consider Vega to be the future of fashion. There are a lot of benefits here other than just reducing with less waste. Yeah, near zero waste. We have no inventory, so we're not just cranking out 10,000 pairs of pants and they're sitting in a warehouse with their fingers crossed that they're bought. We wait till someone is scanned, or we have a small batch order that people are scanned for, and we make those pants. And yeah, within 20 minutes, we can have someone come in, do our scan, we get those patterns generated, throw it up on the machine and run it. And then yeah, that zipper and button in-house. And then yeah, we have full, I say jacquard, I'm from the South, go pack. So we have full jacquard capabilities, which is yeah, very fun. We can weave Kevin's face into the pant, or do things like herringbone twills. Yeah, satines, all that type of stuff. Next slide, please. Yeah, and so now these are just some products that we have made. We can kind of see the one in the top left corner, bottom right corner. These are a bit of our creative samples, you could say, where we were lucky enough to work with different designers. We were down to try the funky materials while also still being able to make your standard pant you would see kind of like on the shelf in your big retail stores. With our machines, our weft is deposited continuously. We don't have those side seams, and we're also rather gentle on those materials. So if you want to get some like sparkly, fine craft yarn almost, we're able to put that in our looms. Next slide, please. Yeah, and this just continues to kind of show the range of the products. All of these are a 2x1 basket weave that we've been able to work on with one of our iterations of our machines. Yeah, basic, not so funky, your consumer won't buy it, but they are a reliable, durable product that you could envision on someone. I know personally I would wear the garments in this slide, maybe not the unique ones in the first one. Yeah, and then also handbags. So many products we consume are just tubes. So yeah, we have a big range for sure. Next slide, please. Yeah, and then these next two slides will cover different case studies we've done. We were lucky enough to work with Eckhouse Lotta. It was an amazing experience. They were able to come to our facility when we were in San Francisco on that proof of concept machine, and we just had a design session where it's like, all right, there's this funky material. They said we want it to look like this, or we want the material properties to be this, and we were like, cool, we can do X, Y, and Z, and we just iterated there on the machine. Yeah, the far left photo, that's like a blue rubber medical tubing material. It was super funky, but fun to work with. Those two middle photos also show kind of more plastic synthetic materials and also our jacquard functionality. And then the two photos on the right were pants we actually produced and sold in small batches. Yeah, it was a really cool experience. And then, yeah, of course, getting able to work with the creatives while showing them our hardware. That was a cool moment for us. I think we really got to see it all come together. And then, yeah, the next slide is this is on a cross, I believe. My super talented coworker, Elizabeth, she actually made the jacquard files for these pants and wove them. So it was cool to have a designer not only interested in the material side of things, but also our jacquard capabilities and be creative. This was another small batch made to order run that we did on our proof of concept machine. Next slide, please. And then, yeah, what is the goal with these looms? The micro factories are the goal. We want to be able to produce where that material is made and sell them where our customers are. We're not getting yarn from North Carolina and then sending it to Turkey or something like that to get woven, and then Mexico for cut and sew, and then a dye house somewhere else. We want to make our garments have that small radius, be ingrained in that community, and really reduce those supply chains while reducing waste. Yeah, we want to partner with different manufacturers too and kind of encourage the industry to eventually make this shift using machines that are more sustainable. They're also faster. And yeah, the looms we have, yeah, I really hope are going to change the industry if we can get adaptation in these mills for sure. Next slide, please. Cool. And then, yeah, some just LCA stats for y'all. So kind of a little bit of proof from what we've been doing, trying to ensure we are having the impact we intend to have. We don't want to just get into the fast fashion game and continue to overproduce just because we can do it faster and more efficiently. So yeah, we want to, reduce these CO2 emissions. We have less energy consumption and less water consumption as well. And yeah, there's a link to the LCA, and I believe that is on our website. But yeah, that's all from us. I want to say thank you. And PS, we are hiring for textile engineers and textile technicians. You can see that on our careers tab on our website. Awesome. Thanks, Russell.
Thank you so much. Are we on to the Q&A session now?
Sure, and maybe I'll just add a little bit about like our stage of company, and Russell talked about it, which is great. But just to kind of give some numbers and understanding for where we're at, because we are a startup. I mentioned we've been around for about 7 years, and we've taken bite-sized chunks of this bigger thing, and we're currently at the stage of taking contracts that we've signed with brands. So what in the startup world, people throw around the term offtake agreement. I don't know how far it goes beyond the startup world, but the idea that if you make these products that we as a brand want, like, Adidas or Zara, whoever, they would be willing to buy them. And these are, we only want to sign the big ones in order to convince, the manufacturers to work with us. So we're at the point where we've got a lot of brand interest for really large contracts from brands, but now we're turning to contract manufacturers who typically make for brands, and we say, do any of you want to work with us on these contracts? What it entails is putting a machine, or lots of machines hopefully, in your facility, hopefully near shore, onshore, close to where the demand is, in order to fulfill those contracts. So we're currently at the stage. Sorry, someone's like really calling me. Hopefully you can't hear it. Yeah, so that's our current trajectory. We have one facility in the EU that we're sending machines to at the moment, and we're very much looking for nearshore option for our Walmart contract here in the US. And so we are also looking in the Americas, but are emphasizing the US to fulfill our contract with Walmart. And we have other contracts actually in negotiation with Walmart as well. So far our product development has gone so well that we've expanded beyond just the pants that we originally signed on with them. So just a little bit of context there before we go into questions.
Awesome. Okay, well, Apurva and I are going to take turns asking the questions. So the first one is from Laura Pritchard, and she says, is a tube the only structure that you can weave?
That's a great question. So when we first, we've had a few different iterations of looms. Russell talked about like the first iteration. So that was when we were, oh my gosh, these people. Okay, I'm turning off the phone. So that was the first of the, well, actually, the first of the more industrial kind of level. But our first iterations were circular, and then they went to kind of topographical, if that makes any sense. More, I always get made fun of for saying this, but like 2.5 dimensions. So instead of a flat fabric, you've got like topography to it. And we have created IP around that. We've created really rudimentary machines around it, but we didn't see as much of a pull from the industry. And also it's just a slower process. The weaving that we're doing right now is extremely fast. We can do a bag in less than a minute. We can do 2 pant legs on the machine in less than 10 minutes. It's a continuous, like all the yarns, you got almost 3,000 yarns coming together all at once. So it's just a lot faster than like a 3D knitting would be, where with like 3D knitting, you typically have like a Z layer added, and it's much slower. So here we have a lot of, there's all going together at once, and they're not changing direction. They're just a continuous movement. So to answer the question, we're very focused on this current architecture and setup, but we have some IP around other architectural setups and would like to combine them in the future, where we get more amorphous, asymmetrical kind of shapes as well. And if there are ideas around it, let's chat.
Apurva, you want to go next, or? Well, the next question is really, it's about how long does it take to create the garment? But actually you mentioned it was 10 minutes for 2 pant legs. So, but what about fully finishing the garment? You have to still sew on the waistband and the belt loops and the zipper. So you have to partner with a garment factory to do that, or are you doing that all in-house?
That's a very, very relevant question for us right now. We have partnered with factories, and we have that one in the EU that we're currently partnering with. But we also know that there's just a lot more speed to moving, just controlling as much of the process as we can. So there is also talk of opening up our own facility. But yeah, the simple answer is that we work with others to complete those products. We have different metric. I mean, every product's gonna be a little different. For pillows, for example, we're able to basically have the time that it takes to produce them, and we have it looks like it will be possible to make this onshore for like even Walmart, which has not been possible for them before. To, I guess, ground it on something. For pants, what the model that we've built out with them and have tested is that it's an extra 10 minutes on the finishing step. So 10 on machine, and it rounds out to about 20 minutes. So just under 10 on machine, just over 10 on finishing steps.
The next question is from Maria. Can stretch fibers be used, and can it be weft knit constructions?
I'm gonna let Russell take this. Russell ran the first stretch yarns.
Yeah. We started like a year ago. We threw some stretch in the loom, and we were just kind of like, oh, cool. And then yeah, more recently, we've experimented more with different fabric types, fabric structures, trying to get a 2-directional stretch, work with 4-way stretch, and everything like that. So we have been very pleasantly surprised with the performance of stretch. I wasn't being as optimistic as I should have been, but yeah, we've been able to make a decent amount of yardage and some prototype garments as well to talk to brands like Walmart and Decathlon with. So yeah, and yeah, different structures, full jacquard capabilities using our design software. Anywhere from weaving someone's face into it to like a double cloth. Yeah, we have that range of abilities.
So I actually asked the next question, but I saw in your video, like there's no warp beam created at all. So everything is feeding into the machine through a creel, right? All of your warp yarns and your weft yarn as well. How is the weft inserted? Is it through a column of air? Is there a tube in there? How are you inserting the weft? Is that your proprietary information?
Oh, no. Yeah, air, water, rapier, all those other kinds of looms would be so cool here, but it's just unrealistic for us to do that in the next year or two. We're working from shuttles and depositing with physical shuttles.
Okay. In a circular fashion, though. So the shuttle is going around this way. Oh, okay.
Yeah, does anyone remember what a shuttle is? Just kidding.
Yeah.
But
they must be tiny. They must be really small to be able to feed in you. Regular sized? This big? I gotta see more of this. I'm very intrigued.
Yeah, come visit us.
Yeah.
You can see it in person. Yeah. They're big enough to hold, what is it, like at least a pound of yarn, right, Russell?
Yeah, if not over, you would only need to do like one material swap per like 8-hour shift. They can hold a decent amount of yardage. And then yeah, we are weaving directly from creels. I love it. I don't have to have a warp prep division. Nothing wrong with warp beams. But yeah, having that taken out of the system is easier for us, as well as if we want to do a quick, cone swaps, we want to add like a strip of hot pink yarn. We just cut the package, tie knot, and you're good to go. You don't have to scrap a whole beam or hold that inventory as well.
You still feeding the warp yarns into like heddles to control the individual yarns being lifted and lowered? So there's still some prep, right?
Yes, that's the biggest prep would be setting the warp. The weft for Russell or others who are on the machine a lot, like you can do that faster than you change your toilet paper.
Oh, wow.
For me, but they're good. They get really good at it.
Yeah,
we've had we have full team parties where we just get the whole squad on there and tie knots together. But we're getting big enough that we're not quite having these parties anymore, sadly.
I had the next question. As our bodies change, can these garments be deconstructed or quote unquote unspun and made into different sizes? Because the idea of designing a garment for a particular size, very good for your size, is great. But some days we have bloating and some days we feel different about our bodies. How does UnSpun help accommodate almost like a Good American sort of a thing? The brand Good American, the way that they have one pant for 5 sizes. Is that possible?
Do you want to take this one, Dan?
Yeah, well, I mean, definitely from the first part of the question of like, can we unspun a garment? We have done experiments with that, and we've proven that we can, because of the nature of the garment being basically a tube that is made with shuttles spinning around. You can think basically from bottom to the top, it's 6 weft lines all spanning the entire length. So you could take that, unwind it, and then re-spin again. I don't think for one specific individual, right? I don't think we would necessarily say, okay, we'll take your pants back, we'll unspin them and then respin them for you. Oh, maybe, but more of like end of life. We're thinking about garments long term. What do we do with them? And we could have sort of like a recycling type of program that would be likely a lot more efficient and interesting than just shredding, down to the fibers and downcycling. But yeah, as far as the garments, like having one garment that can fit sort of at multiple sizes, we've, I think pretty much the standard type of, do we have an adjustable band? Do we have, buttons at different widths or something like that I think would make sense. Also some stretch, we've done experiments with stretch and we've found it to work quite well.
So the next question is from Brenda. And so she says, conceptually, this is similar to tubular knitting. Can one tube run have varying diameter? For example, a more tapered leg, or is it one diameter for the full tube? Because I'm thinking, if you have a set of warp yarns in there, it's going to be very dense if it's a narrow part of the tube, right? And loose at the top.
You want to take it?
Yeah, so yes, we have the ability to vary that diameter in either direction. And thankfully with our design software, we have a lot of knobs we can turn to ensure that fabric weight is maintained through some IP items and whatnot. Yeah, we have ensured like our GSM is within like standard uniformity percentages that you see on the market today. But yeah, you can change, go in, go out. If you want a skinny jean or a boot cut, yeah, that range is available.
I think the next question is, how fast are the looms? I know we've answered it a little bit here and there.
Go for it, Russell.
We can, right now we're cranking at around, we can crank up to like 800 picks per minute. You're gonna hit a material limitation before our hardware maxes out. So yeah, you're gonna have to, maybe slow a little down for cotton, but if we're doing like a protective like motorcycle pant out of Kevlar, you could kind of let it rip a bit faster. So yeah, 800 ppm is our like software maximum right now.
And on our old machine, remember when we were sending it off, rest in peace, we ran it to 1,000 ppm, and it was, excuse me, and those were really thick yarns because we only had 700. So we probably could have cranked, I don't know what the math is on that, but I guess we could have cranked out a pair of pants in like 2 minutes or less maybe. But the room was rattling. It was awesome and scary.
I have another good question from Alan. Can the technology be used for manufacturing blue jeans that will receive a post-wash? And how does the process compensate for shrinkage and torquing of denim?
Yes, great question. It's really relevant to what we're thinking about. So Russell talked about being able to get different weave structures. So because blue jeans are typically a 3x1 twill, we can engineer that into the code for running through the machine. And then you would just swap to the standard yarn. So you'd probably have an indigo warp and you probably have a, undyed weft, and you'd run it that way. We have never put indigo on our yarn, on our machines, because we don't want, you really can't go backwards. It kind of becomes contaminated from there. So we are looking out for partners who want to commit to machines as being, these are indigo jeans, weaving machines basically, but we're not there yet. We have done, oh yeah, I'm in our design studio for a reason, so let me show you some products. We've done some wash downs on non-indigo, so here a black, and this kind of answers your other question on, all right, if you have, we can technically make a denim fabric, right? Like that's more defined by the fabric, but can we really make jeans, especially if they don't really have seams? And that's up for debate. I think every denim head is going to have their own answer to that. We're a little, as you can tell, probably by what we're doing, we're a little more open with our definition of jeans. So we would still probably call them jeans, but the construction would be very similar, in the top block, and this hem would be exactly the same. You're just missing the inseam and the outseam. So if you wanted to, the jeans are about the highs and lows that you get from like the wash down. You can still get that in some of the finishing steps, but let's say if you do want like an inseam and outseam wash down effect, like the highs and lows, you would probably want to like weave in a different kind of thickness in that area, like maybe swap out the warp there so you get something that might react differently in the wash. There are a few different like ways to do it, but we kind of like them without seams. They work really well and they're more comfortable anyway.
The pants that you have there, are they garment dyed?
Yes, so these ran through, I'll show you what they looked like before. Okay, so they ran through the machine as this grayish. It's a 2402 cotton. And then we did a garment dye, like you said, black garment dye, and then a rinse wash over that. Yeah, so that part's not new. Like we're just fitting into the supply chain there. We can also do yarn dye or it could be dyed at any stage. It's very similar to like how decisions are made, I think, in the typical supply chain.
Very interesting. The next question is, how do these contracts work with big box stores if the production is more so on demand?
Good question. Yes, so we're definitely like going after this longer term of trying to perfectly match supply and demand. There are a few approaches we could take. We could say, all right, we only want to work with small independent designers and do the on-demand model from the start. And that's sort of how we started with some of the initial runs with the Vega machine. But our goal really is to make impact and have an influence on the industry as soon as possible. And working with the smaller brands is a goal longer term, and only because the impact isn't there as much. We'd like to lift them up, but instead we want to change where the problems are today. And that's really with the bigger volumes. So our two biggest contracts are with Decathlon Sports in Europe and then Walmart here in the US. And those, we've talked to them about the on-demand model, and it's definitely in the long-term plans. But for a couple of reasons, we don't want to pursue that quite yet. One is UnSpun would love to kind of hold that as a pinnacle, like a higher premium to start, and maybe not go to market with these more accessible brands from the beginning. And another is that it would be kind of surprising for their consumers to walk into a store and to order something and then get it later. Like they're not quite ready for the on-demand versus where their minds are at today. So they're used to supply chains that work on these bigger orders. So we're trying to take baby steps in moving them towards like an on-demand model. So for example, with Walmart, we're very much trying to reduce their lead time. And so still big orders, but by reducing lead time, we're able to, and localizing, we are able to make those big reductions and convince them that this process is reliable because it's so different from what they're doing. Then once they're convinced, then it's like, okay, now we can try this on demand.
I like this one out. Okay, next question. Would you be able to share details about funding as a startup? Or did you partner with a university or other company in the beginning?
Yes. How detailed do we want to get? Okay, so we've gotten funding since 2017. We started with a few different accelerators. Like our first check it was a $20,000 check from Summer at Highland. It was like Highland Capital Partners. It's a VC in Palo Alto, and they just cleared out their waiting room, and they brought in 5 companies, and we hung out in their waiting room for a summer. And so that was our first money. Then our next money came from the National Science Foundation. Amazing group to work with. It's through the SBIR program, which some of you might be familiar with. But basically, any agency, I could be wrong on the numbers, but high level, any agency that has over $1 billion in budget needs to allot 1% of their budget to small businesses. So this SBIR program is awesome for funding new research. We also received money from another accelerator called HACS, and they are at the time they were actually based in Shenzhen, China. So we lived in China for about half a year building our first prototypes, and then brought those back to the US. Then we raised four rounds of funding. So we came back to early 2018. And then since then, we've raised pre-seed, seed, A, and just closed our B this summer. I'm happy to tell you more about all those. I just don't want to bore people.
Awesome. The next question is, with customization, being able to swap the loaded warp is critical to meet the needs of different end users. How quick is the warp exchange process?
Yeah, that's not quick right now. And we don't really have, I'm sure a bunch of you went to like ITMA, like, yeah, there are companies that are working on like automated processes to swapping out warps. I think our first goals are more centered around these contracts for the bigger brands where you set up a machine and it's good to go for 6 months, like really shortening supply chains. And if we do get to a place where we want to make the warp swapping more accessible, I think then we would partner with a group who's already been thinking about that, because I think that's a little bit too much for us to take on at the moment. Something that maybe is noteworthy is behind me. These are old. These are old swap. Are they all? Some of them are from our first machine, and anyone that looks kind of dark has a black warp, and any that's light has a white warp. So it's either all of these fabrics are on a black or a white warp. They're basically all like, so those two are the same as that, as that, as that. And you get just really, really different effects by swapping out the weft. And that's something that's been very interesting to our partners, where they can leave the warp and then get drastically different results just by the quick weft swap.
Next question is from Maria. Are there limitations on yarn size that can be used and fabric weights? And how light have you been able to weave your fabric?
I think the lightest we've gone is like just under 200 GSM. I think technically we could run like a 20 single. You've tested before, Russell, like a 20 single, but then you'd have to be, so you think about it, like they're about 3,000, almost 3,000 yarns on that machine. If you take a cross section, you take like the circle of that and you have 3,000 dots around a circle. The smaller the yarn, the smaller your circle. So it's just a constraint there. So for example, we've got a 24/2, like a 12 cotton count on the machine right now, and that can do it's like 42 in the mid 40s for circumference in inches. And so lightweight, so lightest weight is like, yeah, around 200 GSM. I would say like these pants are probably just under 300. And what other question am I missing? Did I hit most of it?
I think so. We just asked about limitations on the yarn size. So you said it can go down to maybe 20s.
Mhm.
The biggest limitation that we always emphasize is strength. Like if you pull with like 10 newtons of, it needs to withstand like 7 to 10 newtons of strength.
Hmm.
Of force.
The next question is from Becky. Also, what is your warp density on your machine? Are you able to manipulate warp density as well as weft density when weaving?
So Becky is a textile professor, so she's going to ask lots of technical questions. Thanks, Becky.
Yeah, Russell's nodding her head. I mean, it's hard, but Russell's a magician, just figured it out.
I've got some great software that I can use to help me. But yeah, we can vary EPI and PPI. Like as long as you're not making a cheesecloth, you can have fun with it for sure.
Okay, so next one's from Mark. Talking about the fit, form, and function using elastomeric yarns from the 3D scan to designing dimensional stretch so the customer gets perfect fit on the skin. So he's asking you to talk about the fit, form, and function using elastomeric yarns. Is that just a statement, Mark, or is that a question?
Yeah, that's a question too. Like how do you compensate for what you have on the loom versus when you 3D body scan? That's a kind of a stagnant sort of measurement. And then when you take elastomeric yarn and use it in the UnSpun system, how do you then compensate for the stretch of the fabric in order to get it on the skin to fit properly?
So there are a few different, Dan can talk to this better than I can, but like there are a few things we think about with like body scans. Like everyone has a different level of like I would call it durometer if you're talking to a material scientist. Like we're all squishy in different ways. So that's something that we have been able to really, you can't get that with a body scan. Like there's nothing going in and pinching you, but there are, with well over 10,000 examples to work from, we have been able to see where things don't fit over the years and understand, because the customer usually tells us too much, which is amazing, about what worked and what didn't work. And so you get to know where it does fit and where it doesn't fit. And then that goes back into our system, kind of like an AI, to get better and better. And then as it relates to the machine, just like with any loom in running an elastomeric or stretch material, you're going to have to think about how much tension you're holding it under. So that could, because if we really pull on it, let's say that we really want to have just a certain amount of tension on that weft, and you weave it, it's really going to shrink in as you're weaving it, right? Because it's relaxing. So that's just something that Russell and textile engineering team is always thinking about, like there's so many effects along the process, and that's not there's the way that it's being formed is unique, but this is not a unique problem to us. Like this is something that you think about when you're weaving with in general. Yeah, I don't know if that answered your question though.
No, it answers my question.
Okay.
As long as you didn't seem like shocked by it, like there's a that the overall bridge of technology, in the thought process is can be compensated or looked at intelligently in this way. That's all you can begin to ask with this.
We do.
Yeah, and a lot of it. Oh, sorry.
Oh, I was going to just add at least to the custom gene side, and Beth, you're totally right that basically with all of the data inputs, it's become easier for us to sort of make the right guess. That you can look at certain body shapes and have an okay understanding for what the compression there might be. Though definitely the more answers to questions somebody provides to us, if they tell us they're their height, their weight, their age. Those things can also add to getting a better idea of that. Yeah.
Christina, thanks for letting me ask my question personally. Appreciate that.
The trick is to just make your question statements, and then we'll let you ask them.
Yes, I'm very,
Totally
very familiar with that methodology.
The next question is, you just mentioned Kevlar and cotton. What are the different types of fibers you can handle? What is the Decitex range?
Yeah, we've done a very wide range of materials. Thankfully my product team lets me be a little creative, and different brands will talk to us. So we've run anything from like pineapple fibers to like 150 denier staple filament. I think it was poly. So yeah, just a wide range of materials. As long as I have a decent TPI or mechanical entanglement or some type of calendar heat bonded along my yarn, I'm pretty happy with anything. I know, personally, I prefer a staple fiber, but that's just because what I'm used to working with. But we've done synthetics. Think about with Decathlon, they're in the athletic space, so they're going to want something that's a bit more performance focused versus if Walmart wanted a more comfortable, like relaxed, I don't know, golf pant or something, you're going to go with a softer cotton. Yeah, so I think with materials, you're going to want to, of course, want to consider like cover factor when going into that decision about those sizes of yarns. But yeah, other than that, we've been able to run with a lot of things, even your fun, like crafty, like knit yarns. Like I ran like a 10-2s the other day, nice chunky thick yarn, and it did totally fine. So yeah.
Top question from Becky. With your setup, have you experimented with warp lay-in or birotational or alternate motion shuttle passes?
We have alternate, like changing direction would be so cool, because then you can you don't have, like if you have an arm side, like a hole in your arm, you just like don't have to cut it out. You just, or like for example the rise, we don't have to cut that. It would just it would basically create a selvage where you would have the rise. We've not done that. That would be, I think we're optimizing for speed here. We want to make sure, like, the one thing about our industry is it really knows how to cut pennies, and if we're not faster and cheaper, we're not going to win. Like these brands are not signing with us because of the sustainability. As much as they talk about it, it's not the reason they're signing with us. So unfortunately, we haven't put any focus into some of those alternate methods, but hopefully we'll have some room to play in the future. We're trying not to, we do nerd out about this stuff though, so we have to hold ourselves back and not get too distracted.
Speaking of, I guess, speed, could you potentially see a company having two machines, one with black and one with white, to prevent the downtime?
100%. Yeah, we want them to have 50 machines. Like we want them to have a lot of machines, and we want them all to and they're different models. So you can think about, like, maybe Walmart has a model where that is a constant, that machine is for chinos and chinos only, and that's just going to run year round. And then there's another machine in the corner that's for independent designers that gets swapped out on a more continuous basis. And maybe it's just, it probably will be a slightly higher price point, but a lot more competitive than, even because right now I remember when we were starting out with our D2C brand, we looked pretty silly. We were running around LA saying, hey, we just created this software that allows you to make custom fit, but we haven't created our hardware to make this yet. Can you help us with the cut and sew? And then they'd say, how many do you want to make at a time? We're like, one. Can we make one of each? And they just, they don't say anything. They just kick us out the door. So minimums are a huge, huge problem with the industry. And we want to, longer term, be able to, we would love to solve that right now. But again, like picking and choosing our battles. But yeah, having a machine that would be like, okay, that's the one-off machine, and you just pay a premium to use it.
Here's the question about cost. How much does a full-legged pant cost? And is there any volume or scale impact to cost using 3D weaving? Because I guess you're working with Walmart and they are penny pinchers. So I guess we're all wondering, how much does it cost to make a pair of pants using your method?
Well, I mean, I can't tell you the actual, because like, you know, that if you're asking about cost, you know that there are so many different variables that go into it. But for example, we had a 30% reduction on their cost for US on a costing model we did last week with Walmart on a chino. So I have to look back if it was like Bangladesh to the US, like Bangladesh standard process to US process with UnSpun. I think because that's ultimately what we want, and we want this to be cheaper. The thing, or we want it to be on par, and then to have the other aspects of it push them in this direction, because supply chains are extremely risky. There's shipping across the world. There's tariffs. There's like all these things that kind of get in the way, and we want those to be comparable, but then everything else to add up to let's make this local and make local kind of the obvious decision. So I think that model must have been local to local, and UnSpun's process being 30% cheaper. But I hope I'm wrong about that. I hope it was Bangladesh.
Awesome. The next question is, if there is a yarn break in the warp, does the machine have the capability to identify where and when it happens?
Yes, and it is better than your standard drop wires where you have to run your hand across and hope you feel it. Yeah, we got your standard break detection, metal to metal, closed circuit, and then our software like pinpoints it exactly where it is. You just throw a warp dresser knot on it and keep going.
Another weaving question, does your process still require the warp yarns to have sizing agents, or does your process reduce the likelihood of fibers or yarns breaking or flopping while weaving?
We don't use any size or waxing at all.
Right.
We have a couple times, but we don't need it. So why do it?
Mhm.
When we go down to 40, 50, 60 singles, we probably will start needing that. But we're on we're on 12 to 16 cotton count right now, and those have been fine.
This is a data security privacy question. Are there no privacy concerns around personal 3D body data sharing? Oh, wait, I missed a question. Sorry. Christina, you can take the other one, but yeah, privacy question.
So the question about concerns with data privacy. So we have for third parties, when we've built tools like this before, for example, we had a fairly high profile partner in Europe recently, and they had very, very strict privacy considerations. And basically the way that that partnership worked is somebody would scan their body and we would process it into a 3D mesh, and then we would delete all of the original images. And even UnSpun would not collect the individual's name or sort of any like personally identifiable information. And so at that point, we just have a mesh with sort of like an ID number, and it's up to the customer, the third-party brand business that we were working with, to join those together with their own library of like, this person is this ID, and we know who that is. On the UnSpun side, of course, we do need to be able to put those together, because if you order pants from us, we need to know who they go to. But we do have a pretty strict set of protocols here internally over who has access to the data. And if anybody contacts us and says, hey, I want you to get rid of that, or I want you to update it, we do allow for that. It's California has a privacy law fairly similar to the European one, and so we follow that, and it requires a lot of that type of compliance.
Mm-hmm. Are there any experimental ideas you've had to reject because they were too complex?
How much time do we have left? Yeah, so many. I mean, if you look at all, basically our idea, we would like to help the wovens market. We want to change the way wovens are produced. So so far we've only been talking about pants, pillows, and bags today. There are a lot more products out there. And in order to not kill ourselves, we've had to decide to just focus on these. We do have some performance contracts that are starting to come into play, and we have to be careful about how much we dive into those. But yeah, I mean, looking even at other industries is something that we've had to kind of put on hold. So the answer is everything but pants, bags, and pillows.
Interesting. Which countries are your yarns coming from?
Right now, the US, Turkey, Korea, like Senko, Shuford, and I don't remember the name of the one in Turkey. No, Senko's in Turkey. What's the one? Bueller. Yeah, those are, I don't know. Those are just a handful. We work with anyone. And then we have a ton of innovator yarns too that we work with. And I'd say most usually come through, and most of them usually work, because you just never know. They're all really new at developing these yarns. So like Russell was talking about earlier, like testing lots of different yarns. Our goals, we would love to be part of the fiber shed model. Like we're localizing manufacturing, getting close to where the demand is. It's not in our power to necessarily start setting up spinning mills and planting our own farms, but we'd like to help with that ecosystem and be able to create more fiber sheds in the future.
Okay, so last question. I know you mentioned that the finest yarn you've used in the weft is 20s. What about in the warp direction? Is it also that fine, or is there a limit to your warp yarns?
Yeah. We've probably gone thinner than that, just with the number of things we've run in the machines. But like some of that conductive fiber, some of that conductive yarn was super thin, and there have been some really tiny filaments that we've run through. So things run. It's just, what's the cover? Do you have enough cover on that end goal? And if you don't, you really have to shrink the product.
All right, that's it. So thank you so much for joining us today. We really enjoyed learning a little bit more about your Vega machines, and hopefully the questions were not too technical or tricky. But as you can see, this is a great topic for our material interest group members at AATCC to listen to. If you guys are not members of A Squared, consider joining. We would love to have you. You're probably using AATCC test methods, I'm sure, to test all of your materials. Anything else that we need to add, Maria, to our conversation before we wrap up?
There's
Just
one more
brief.
slide, I think. Yeah, one
Just
last one.
briefly, a commercial for the next AATCC paid conference in Grand Rapids, Michigan, is a odor and microbial management conference.
This is a great one to go to. I've been to it twice before over the last several years, so definitely hit that one up.
And if anyone needs anything from our membership staff, here's the contact information.
Right. Well, thank you so much, everyone, for joining us today. And if you missed it, tell your colleagues, your friends that it is recorded. If they're members, they can access the video shortly on our AATCC website through communities.
And